Hello and welcome to this video. This video is the eighth video in the Bridge course, class 9 to 10th. And in this video, we will be talking about word problems, how to read word problems, how to understand word problems, and how to translate them into expressions or equations. I have a few word problems which we will go through one by one. I will not be solving them, but what we will be doing here is I will try to make you understand how to break the word problem into small pieces and write them as equations. Okay, we'll start with the first one. I'm going to read the equation, the problem here. The sum of the squares of two positive integers is 208. If the square of the larger number is 18 times the smaller number, find the numbers. Okay, I've read them once. Um, I mean, I would suggest you read them twice before you start doing anything with them. But in this case, what I'm going to do is that I'm going to look for what I called as things or objects in the problem. Let me read again. The sum of the squares of two positive integers. Okay, let me put this thing here. There are two positive integers. They are things. So let me write down first positive integer as x. I'm just going to give them names. Second integer, I'm going to call that y. Okay, two positive integers, I gave them names. Now let's go a little bit behind and see what they have to say about the two positive integers. The squares of the two positive integers. Okay, one integer is x, other integer is y. The squares of the positive integers will be x square and y square. Okay, so now we got two pieces of the puzzle. Now let's go a little bit backward. It says the sum of the squares of the two positive integers. These are the squares of the two positive integers. Sum means what? Sum means to add. So you add them. If you add them, x square plus y square is what is meant by this line here, the sum of the squares of two positive integers. Now we come to the main point. The word is. Is mostly means is equal to. Is equal to. So this part, the sum of the squares of the integers is this, and this is equal to. That is what is says. And it is equal to what? 208. 208. So this is the meaning of the first sentence. The sum of the squares equals 208. So I have translated the first sentence. Let us look at the second sentence. If the square of the larger number is 18 times the smaller number, find the numbers. So what are the things here? One is a larger number, one is a smaller number. So there are two things. We have already defined them, x and y. But they're talking about larger number and smaller number. We don't know which one is which. So I'm just going to assume y is a larger number and x is a smaller number. So what are they saying? The square of the larger number. Larger number is y. The square of that is y square. Correct? And the smaller number is x. 18 times the smaller number. This part. So we've taken this part, the square of the larger number, and we got this. So now 18 times the smaller number. What does that mean? Smaller number is x. 18 times the smaller number is 18x. Okay, 18x. So we got this part covered, this part covered. Now what they're saying is that if the square of the larger number is 18 times the smaller numbers, if the square of the larger number, which is y square, let us say y square, is equal to 18 times the smaller number, 18x, from these two things. If this is equal to this, find the numbers. Find the numbers. What does that mean? Find x comma y, because those are the numbers that we named. So I got the equation. Second, I have another equation, y square is equal to 18x. So now all I am left with is these two equations. And using this, I have to solve them and find the value of x and y. So this is how you break down a problem into smaller pieces and translate them into equations. So let us take another example. Okay, so this is another example. Just like the previous example, I'm going to read this and I'm going to find the things in this problem. Okay, reading it. The sum of ages of a father and his son is 45 years. 5 years ago, the product of their ages in years was 124. Find their present ages. Okay, what are the things in this problem? One is you have a father, you have a son. But the things related to the father is the father's age and the son's age. It says ages of father and the son are the two things in this problem. So let us say X is age of father. This is one thing or object. Y is the age of son. So we identified two things so far. So now let us look at, just go a little bit back and read it. It says the sum of these two things. That means these two things are x and y. The sum of these two things is x plus y. So this part we looked at, this part we looked at, and now it says is 45 years. What is 45 years? The sum of the ages of the father and his son is 45 years. Is means equal to. I've said that before. 45 years is 45 years. So this is the first equation that is framed from the first sentence. Okay, let us keep this separate. Move it a little bit here. Now let's look at the second line, second sentence. 5 years ago, let's split it. 5 years ago, the product of their ages in years was 124. Okay, if we take 5 years ago, the product of the ages in years was 124. 5 years. So currently the son's age is, the father's age is X, age of father. The age of the son is Y, age of son. 5 years ago, what would have been the father's age? X minus 5, right? And the son's age would have been Y minus 5. Because 5 years ago, it would have been 5 years less. So 5 years ago, these are the ages of these father and son. The product of their ages in years, the product of their ages means that these are their ages. These were their ages 5 years ago. Product means you multiply. Product means you multiply. So x minus 5 into y minus 5. You multiply the two ages. Was 124. Is, was, both are the same. They're similar. Was and is means equal to. Equal to what? 124. And find their ages, which means find the value of x and find the value of y. So this is equation number 2, and this is equation number 1. You solve these two equations, you get the x values of x and values of y, and that will be your answer. So what did I do again here? I first tried to find out the things in the problem. Then I tried to break things down, break the parts of the problem down, and try to attach it to the things, and then frame the equations or create the equations, and then we are ready to solve. Okay. Um, This is how you break a word problem into smaller pieces and try to attach the meaning to the things, what I call as things in the problem. Let's take one more example. Okay, this is the next example. I'm going to read the question first. A motorboat whose speed is 18 kilometers per hour in still water takes 1 hour more to go upstream then to return to the same point. Find the speed of the stream. So you have the motorboat. Uh, First of all, it goes upstream. Upstream means against the flow of water. Water is flowing like this, and the boat is going against the flow of water. So upstream, it goes against the flow of water, and when it comes down, it's called downstream. Okay, so now that you know that, we will try to find out what the things are. Okay, first we have a motorboat. That is a thing. But what is related to the motorboat? Speed. So the speed of the motorboat is a thing. So let us say x is the speed of the motorboat. Speed of the motorboat. So now the speed of the motorboat is equal to, is means equal to 18 kilometers per hour. 18 kilometers per hour in still water. In still water. What does still water means? Still water means where the water is not flowing this side, water is not flowing this side. So the boat does not have to fight against the water or go in the direction of the water. If it goes against the water, if there is water is flowing like this, if it goes against the water, the boat's speed will be decreased or the boat will be slower. But if it goes along with the water, because the water is also flowing, the speed of the boat will be more. But in the case of still water, where the water does not flow this way or this way, the motorboat will just go along at its own speed. So in still water, the speed is 18 kilometers per hour. So now the motorboat takes 1 hour more to go upstream than to return to the same point. So 1 hour more, let's split that separately. To go upstream, let's keep that separately, then to return to the same point. There are three things that you're talking about here. Going upstream, go upstream, return to the same point, return to the same point, and then 1 hour more, 1 hour more. These are the three pieces of this second part of the problem. So when the motorboat, the speed of the motorboat is x. Speed of the motorboat is x. So when it goes upstream, it has to go against the water. So let us say the water is flowing in this direction at a speed y. Water is flowing in this direction at speed y. So what will happen? The the motorboat takes 1 hour more to go upstream. So this is the speed of the boat normally when there is no water flow. But when it's going upstream, it will have to fight against the water. Its speed will be decreased by the flow, by the speed of the stream. If the stream is flowing in this direction at a speed y, the boat is going in this direction. So the actual speed of the boat will be x minus y because the water flow will slow the boat down. Will slow the boat down by how much? By how fast the water flow is. So when it goes upstream, the speed will become x minus y. So it takes 1 hour more to go upstream. This is the speed. And it takes 1 hour more to go upstream than to return to the same point. Let us say if the distance is x, I'm sorry, the distance is d. If the distance is d, let's do something. Okay, let us say the distance is d. The motorboat is going upstream, it's coming downstream. So if the distance is d, the time taken will be d by speed, d by x minus y. This is the speed when it's going upstream. The time taken while going upstream is d by x minus y. So when going upstream, it takes 1 hour more, 1 hour more compared to what? To return to the same point. So when it's coming back, the boat will come with a speed of x, which is a nominal speed, plus y, because the water is flowing in this direction and it will push the boat and make it go faster. How much it will make it go faster? With the speed of the water. The water speed, if it is x, or sorry, if it is y, then the speed of the boat when it's coming down is x plus y because it's going to be faster. When it's going up, it is x minus y. So the time taken to come down is distance by x plus y. So this distance plus x, this distance going up, this is the distance while coming down. So while going up, it takes 1 hour more. So d by x minus y is greater than d by x plus y. I'm sorry, the time taken while going up is more than the time taken while coming down. How much is it more? 1 hour more. So how do we write it then? Let's change the color. Let me take a color green. So this is the time taken while going up. This is the time taken while coming down. And while going up, it takes 1 hour more. So I can say d by x minus y equals to d by x plus y plus 1 plus 1. Well, if you solve this, you can remove d because it's not required. But this is how you frame the equation. You find the speed going up, you find the speed coming down, and the speed going up is 1 hour more. So this is a slightly complicated problem. It's pretty complicated if you ask me. But how to solve it is break it into small pieces. First, find the things. The thing here is the speed of the motorboat. And then the second part is a little bit more complicated. When you go upstream, the speed decreases. It becomes less. By how much? By y, which is the speed of the flow of water or the speed of the stream. And while coming down, the speed increases by how much? By x plus y. And this is the time taken for going up. This is the time taken for coming down. And the difference between them is 1 hour. And this is equation 2. This is um, equation 1. This is equation 2. You solve them, you will get the values of the speed going up and coming down. Okay, now that we have looked at the problems, we have taken them part by part. Let's just summarize what we have done. Things. When you look at a problem, I take the things in the problem. Let us say in a particular problem, things are x plus y. I mean, x and y. The sum of the things is x plus y. The square of a thing is x square. 18 times the square of that thing is 18x squared. So here, let us take an age problem. There are two things, the age of the father and age of the son. 5 years ago means m minus 5. The father, if his age is m, 5 years ago, his age must have been m minus 5. The product of their ages, product means multiplication. If the ages were m and n, the product of their ages is m multiplied by n or m into n. In the case of a speedboat problem, let us say the time taken by the speedboat as x, 1 hour more means x plus 1. So if you're able to split them into small pieces and add each of these pieces or tie each of the pieces to that thing, then it is much easier to frame the questions or convert the word problems to equations so that we can solve them. Okay, thanks for watching this video. If you follow this, you may have a certain method that you follow, but if you break it into small pieces, if you identify the things first and try to attach whatever is related to the thing, the sum or the square or the number of times, or 5 years ago or whatever it is a lot easier to frame the equations. With this, I will conclude this video and I will meet you in tomorrow's video. I'll talk to you